to describe the domain, range, and the asymptote of a logarithmic graph, it's helpful to remember what we already know about an exponential graph. And so we can take a look at some things we've learned before. This is our exponential growth curve. We've described the domain as all reals in the past. Our range was y is greater than 0, anything above the x-axis. And then our asymptote was that horizontal line at y equals 0. So for a logarithmic graph, because it's the inverse of our exponential graph, everything is just going to kind of switch around. Recall that finding an inverse meant we were switching x and y, and we're going to do a very similar thing to find our domain, range, and asymptote for a logarithmic graph. So for example, our domain was all reals for something exponential. It's now going to be our range that's all reals. The graph of a logarithmic graph, which is shown in red, does go downwards forever. Remember, range describes how high or how low the graph goes. So I can add an arrow showing the graph does go down forever. It also increases forever, very slowly, but it would increase forever. Our asymptote has also flipped. Rather than being a horizontal asymptote, we now have a vertical asymptote. It's going to be right here until we start shifting this in a few moments. It's going to be a vertical line, and because x and y have switched, and because I now have a vertical line, my asymptote is going to be at x equals 0. Okay? And then finally, our domain is again going to kind of flip-flop for our logarithmic graphs. This time to describe domain, I'm going to say it has to be, remember domain is always x, so it has to be x greater than 0. And once again, those numbers will always be the same. They may not always be zeros, but they'll match each other. So there's going to be how we define the domain, range, and the asymptote of a logarithmic graph. Let's go ahead and see how this can be shifted and how those values can change. So right here I have our logarithmic equation with h and k, our good old friends h and k. H is still our horizontal shift, and it does the opposite of what it says, and then k is our vertical shift. The question is, what kind of shift will affect our vertical asymptote? Well, if you imagine a vertical line, because that's the kind of asymptote we have, moving that up or down won't change it. Like if I draw it up here, it's still the same vertical line. However, if I move that side to side, that will change where my vertical line is located. And so what I'm looking for, the specific kind of shift that I want to see, is a horizontal shift. If we have an h value, that's going to change the location of our vertical asymptote. And notice, I'm going to recognize it's a horizontal shift because it's in parentheses. If you don't see parentheses, you don't have a horizontal shift, and that vertical asymptote will not have changed. So here are 3 examples of logarithmic equations. Let's go ahead and describe how the graphs have been shifted and then state the domain, range, and the asymptote. So notice too, I haven't graphed anything. I don't really care about graphing these. If you want to graph them, I would just use a table on my calculator. But for now, let's just worry about describing the domain, range, and asymptote. So first up, I want to describe the shift. Notice this time there's a number inside parentheses. As we just discussed, that's what's going to be a number that affects where my asymptote is located. So I'm looking for numbers inside parentheses, specifically if those zeros from the asymptote and the domain are going to change. So it is a horizontal shift, and it does the opposite of what it says. So instead of it moving it to the right 4, this is actually going to shift my graph to the left 4 spaces. Okay? Which means my new asymptote is no longer x equals 0, it's x equals -4. It's been shifted backwards 4. Similarly, my domain is now going to be x has to be a number bigger than -4. You can't do the log of something negative, so if you tried to plug in a number smaller than -4, you'd have a negative number in parentheses and try it on your calculator. You can't do the log of something negative or 0. And then of course our range is going to be all reals. That's never going to change for a logarithmic graph. In fact, if you want to be really lazy, just go ahead and extend that all the way across the chart. All of these domains are going to be all reals. Okay, let's try one more together, and I'll have you guys try that last one on your own. So be careful with this one. Oh, by the way, notice too, I'm not even looking at what my log base is, whether it's log base 2 or log base 1/2. None of that affects anything about my domain or range. So I don't even really care what my log base is. This time, the shift that's going to occur is going to be a shift that's going to move my graph down 3 spaces. This one always gets people because they want to say it's moved to the right 3. The reason that I know that this is moved down is because it's a vertical shift. It's not in parentheses. In fact, if you want to add the parentheses in, put them just around the x. But that's what gets people. They think that -3 is in parentheses and they try to shift it left or right, but it's an up or down shift. And because it's just been shifted up or down, those that domain and that asymptote have not changed. They remain where they were for our parent function, just at 0. Okay? So I'd like you guys to pause the video at this point and try this last example. If you let the video play through, my work will pop up in just a couple seconds. So there were two kinds of shifting going on this time, a right shift because of the number in parentheses, and a shift that moved the graph up one space. The only one I cared about was the number in parentheses. That's why I identified it with a little star. So that's going to do the opposite of what it says, shifting their graph horizontally. So my asymptote is now at x equals -2, and my domain is now at x must be greater than -2.